Welcome to YQ Academy Object-Oriented Programming Java Interview Questions and Answers. 1. Explain about procedural/structured programming language and its features. Procedural programming, also known as structured programming, is a programming paradigm that focuses on using procedures or functions to structure the code. It emphasizes breaking down the program into smaller, reusable procedures that can be called and executed in a sequential manner. Procedural programming languages follow a top-down approach, where the program is organized as a series of steps or procedures that operate on data. Features of procedural/structured programming. 1. Procedures/functions. Procedural programming revolves around the concept of procedures or functions. Procedures are self-contained blocks of code that perform a specific task. They can take input parameters, perform computations, and return values. By breaking down the program into smaller procedures, the code becomes more modular and easier to understand and maintain. 2. Sequential execution. In procedural programming, the code is executed in a sequential manner, following the order in which the procedures are defined. Each procedure is executed one after another, and control flows from one procedure to the next. This sequential execution makes the program easy to follow and debug. 3. Local variables. Procedures in procedural programming can have local variables that are accessible only within the scope of the procedure. These variables provide a way to store and manipulate data specific to a particular procedure without interfering with variables in other procedures. 4. Control structures. Procedural programming languages support control structures, such as conditionals, if-else statements, and loops for while, do-while, which allow for decision-making and repetitive execution. These control structures provide flow control within the program and enable branching and looping based on certain conditions. 5. Emphasis on data. In procedural programming, there is a strong emphasis on data and how it is manipulated. Data is typically stored in variables and passed as parameters to procedures. Procedures operate on the data, perform computations, and return results. The focus is on the step-by-step manipulation of data to achieve the desired output. 6. Limited code reusability. While procedural programming promotes code modularity through the use of procedures, the level of code reusability is relatively limited compared to object-oriented programming. Procedures can be reused within the same program, but they are not designed to be easily reusable across different programs. 2. Explain about object-oriented programming and its features. Object-oriented programming (OOP) is a programming paradigm that organizes code around objects, which are instances of classes. It emphasizes the concept of encapsulating data and behavior into objects, allowing for modular, reusable, and maintainable code. OOP provides a set of principles and features that facilitate the modeling and design of complex systems. Features of object-oriented programming. 1. Classes and objects. The fundamental building blocks of OOP are classes and objects. A class is a blueprint or template that defines the structure and behavior of objects. It encapsulates data attributes and operations methods that can be performed on the data. Objects are instances of classes, created using the class blueprint. Each object has its own state data and behavior methods. 2. Encapsulation. Encapsulation is the process of bundling data and methods together within a class. It ensures that the data is accessed and manipulated only through the defined methods, providing control over the accessibility and integrity of the data. Encapsulation helps in hiding the internal implementation details of a class, promoting data security and abstraction. 3. Inheritance. Inheritance allows classes to inherit properties and behavior from other classes. It enables the creation of hierarchical relationships between classes, where a subclass inherits characteristics from a superclass. Inheritance facilitates code reuse, as subclasses can reuse the attributes and methods of the superclass and add their own specific features. It promotes modularity and extensibility in code design. 4. Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It enables the use of a single interface to represent different types of objects, providing flexibility and extensibility in code design. Polymorphism is achieved through method overriding and method overloading, where different implementations of methods can be invoked based on the type of object. 5. Abstraction. Abstraction focuses on representing the essential features and behavior of an object while hiding unnecessary details. It allows for the creation of abstract classes and interface that define the common characteristics and methods that subclasses must implement. Abstraction helps in managing complexity and provides a clear separation between the interface and implementation. 6. Modularity and reusability. Promotes code modularity and reusability through the use of classes and objects. Classes can be designed to encapsulate specific functionalities, making them modular and independent. These modules can then be reused in different parts of the program or in other programs, reducing code duplication and improving efficiency. 4. Differences between traditional programming language and object-oriented programming language. 1. Code organization. In traditional programming languages, code is organized around procedures or functions that operate on data. The focus is on a step-by-step sequence of instructions. In OOP languages, code is organized around objects that encapsulate data and behavior. The emphasis is on the interaction and collaboration of objects. 2. Data and behavior. In traditional programming languages, data and behavior are separate entities. Data is stored in variables or data structures, and functions operate on that data. In OOP languages, data and behavior are encapsulated within objects. Objects contain data attributes and the operations that can be performed on that data methods. 3. Code reusability. Traditional programming languages often require code to be duplicated or rewritten for different parts of the program that require similar functionality. In OOP languages, code reusability is achieved through the concept of inheritance. Objects can inherit properties and behavior from other objects, reducing code duplication and promoting code reuse. 4. Modularity. Traditional programming languages rely on functions or procedures for modularity. Code is organized into separate functions that perform specific tasks. In OOP languages, modularity is achieved through objects. Objects encapsulate both data and behavior, making it easier to develop and test modules independently. 5. Encapsulation. Traditional programming languages may lack strong mechanisms for encapsulating data and behavior. In OOP languages, encapsulation is a fundamental principle. Objects encapsulate their data and provide controlled access to that data through methods. This protects data integrity and allows for better control over how data is manipulated. 6. Abstraction. Traditional programming languages may not provide explicit mechanisms for abstraction. But languages emphasize abstraction as a way to represent complex systems in a simplified manner. Abstraction focuses on essential features while hiding unnecessary details, making code more flexible and easier to understand. 7. Polymorphism. Polymorphism, which allows objects of different types to be treated as objects of a common superclass, is a key feature of VUP languages. It enables code to be written in a generic manner, accommodating objects with different behaviors. Traditional programming languages may not provide built-in mechanisms for polymorphism. 8. Collaboration. VUP languages promote collaboration among developers by providing a common framework and vocabulary. Objects encapsulate data and behavior, making it easier for teams to work together on different components of a system without interfering with each other's code. Traditional programming languages may lack this level of collaboration support. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.